In this video, we're going to look at Argand diagrams. We'll talk about what we mean by an Argand diagram and we'll look at an example. So we've been looking at complex numbers, we've defined what complex numbers are, and we've looked at the arithmetic of complex numbers, how to add them up, times them together, divide them, and so on. And now we're just going to look at how we can physically represent complex numbers with a diagram. So there's a very common way of representing complex numbers, and it's very important you understand what's going on. So let's just remind ourselves that a complex number is any number of the form a plus ib, where a and b are real numbers and I is the imaginary unit, of course, which is the square root of -1. So we can draw a complex number on a plane in much the same way we'd mark a point xy on the Cartesian plane. So if you think about real numbers, we can draw those on a line. We draw a line, mark 0 on it somewhere, and this, if you like, represents all real numbers. If you go to the right of 0, you're going up through the positive numbers, and as you go down to the left of 0, you're going down through the negative numbers. The whole line represents all real numbers. Well, we can do something similar with complex numbers, but because they have two parts to them, we need to do it on a plane rather than on a line. So the plane is called the complex plane. This will probably come up a lot if you're studying complex numbers. And when we draw the plane out and mark complex numbers onto it, the resulting diagram is called an Argand diagram. So complex plane, Argand diagram, some people use them a bit interchangeably. The complex plane is more an abstract idea. It's the whole plane of complex numbers, so the whole space of complex numbers. They make up a two-dimensional plane. An Argand diagram is an actual drawing of the plane or a part of the plane with numbers marked on it. So let's see how we build up an Argand diagram. Well, we start with an origin. So we're going to need to draw a plane. We're going to need to draw two axes. So we start with an origin and we draw the first axis, which is just the real line. So it's just the line I was just talking about, all real numbers. So the origin is 0. As we go up there, we go positive, so 2, 4, 6, and so on, and down. We get -2, -4, -6. So this is all real numbers. I've just marked a few on there to give a sense of scale. But this is the real line, and then we take a second axis through the origin, which we call the imaginary axis. So the first axis is called the real one, and this is the imaginary axis. And you can see on here, we just get multiples of the imaginary unit I. So as we go up, we get positive multiples, 1i, 2i, 3i, and of course everything in between, all the decimals. And the same when we go down, but we have negative numbers. So how then do we use this to mark or to represent complex numbers? Well, let's have a look at some examples. So I'm going to put a grid up just to make it a bit easier. And the example is to draw the following numbers on an Argand diagram. So they are these 4 numbers. So let's look at 1, 2 plus 8i. Well, all you have to do is go along the real axis, the distance specified by the real part of the complex number, and then along the imaginary axis, the distance specified by the imaginary part of the complex number, and then you mark a point where you get to. Or you can think about you have to travel along the real axis to whatever the real number is, and then you have to go up or down the imaginary axis to whatever the imaginary part is. So with 2 plus 8i, if we look at that, that's our first example. We go along to 2 on the real axis, and then we go up to 8i on the imaginary axis, and we get to this point. So you see we've gone 2 along and then 8 up, because we have real part 2 and imaginary part 8. So it's very similar to trying to mark a point on a plane, where you have the point will be given as, say, x, y, and you go along to whatever the x value is, and then up or down to the y value, and mark the point there. But instead of x and y, we have the real part and the imaginary part. So in this case, it's 2 and 8i. Now we'll look at the second one, -3 minus 3i, where we just go to -3 on the real axis and then to -3i on the imaginary axis. See if you can guess where this number is going to pop up. It's going to be here. minus 3 minus 3i. Then let's look at the third one, minus 6 plus 4i. So we go to minus 6 on the real axis and then 4i up the imaginary axis to get to here. Minus 6 minus 4i. And finally, 5 minus 7i is here. I've gone 5 along in the positive direction and then minus 7 down. So 7 in the negative direction on the imaginary axis. So all you have to do is look at the number and pay attention to its sign. So 1 and 3 have positive imaginary parts, which is why they both lie above the real line. They both lie in the top half, but then 2 and 4 have negative imaginary parts, so we had to go down the imaginary axis, so they lie below the real line. Similarly, 1 and 4 have positive real parts, so they lie in the positive side of the real axis, so they lie to the right of the imaginary axis. And then 2 and 3 have negative real parts, so they're on the left of the imaginary axis, down the negative half of the real line. So if we now get rid of this grid, we used it to draw them, but we can see that we don't really need the grid. We just have 4 points in this plane, in this space. But any point in this space gives us a complex number. So every single point in the plane is a complex number, not just the ones that were on the grid, but any in between as well. So I've only marked ones with whole real parts and whole imaginary parts, so they're integers, 2 and 4 and minus 3 and minus 6 and so on. But it could be any decimals, they could give you points in between. Anywhere in the space is a complex number, and so the plane, when we take all points together, we get the plane. That is the entire set of complex numbers. So whereas real numbers can be represented on a line, to represent complex numbers, we have to draw out a plane. It's not too dissimilar to when we mark points on a set of axes like x and y points, which we're a bit more used to doing. So this that we have here in the middle of the screen is an example of an Argand diagram.